Welcome to everyone who's joined in. I'm Lavina Ambani, VP Customer Success at Caelius Consulting. And it is a great pleasure that I'm able to present and be a part of a group of women in tech. They're going to be presenting the entire, they've put everything together, they have orchestrated it, and beautifully are ready to share it with everyone who's joined so far, and they're joining in as well. So a round of applause for our amazing women, a super proud moment, I think, for all of us sitting right here to be able to witness this meetup that we're about to present. So moving over to, Kiran, can you move on to the next slide? I'm going to pass it over to Manpreet. Thanks, Manpreet.
Thanks, Lavina. Hi, everyone. My name is Manpreet Sethi. I'm the enablement lead at Caelius Consulting, and I'm based out of Mohali office in India. So I lead various internal training sessions at Caelius, empowering various MuleSoft professionals by facilitating their enablement and enhancing their communication and presentation skills, and organizing various MuleSoft quizzes. So just doing my bit to ensure that this entire enablement process for them is turns out to be a really fun-filled experience. And I'm really excited to be a part of this meetup today. Let me just pass over the mic to Kiranjot to take it further.
Thanks, Manpreet. Good morning, good evening, everybody. Welcome to the MuleSoft meetup. Myself, Kiranjot Kaur. I'm based out of Dallas, Texas. I'm currently working as a solution architect with Caelius Consulting. And I'm so excited to speak about the CloudHub 2.0 key features and use case today. And actually, I'm actually glad to be at this all-women meetup to Caelius Consulting. Look forward to it. Kajal, can you go next?
Yes, thanks, Kiran. Hi, everyone. My name is Kajal Agrwal, and I'm joining from Chandigarh, India location. And I'm really excited to part of this all women in Mule meetup. And welcome to Frisco Meetup, guys. Thank you. I'm passing to Mehak.
Hey everyone, this is Mehak. So I'm working as an associate solution architect here at Caelius. I'm just so excited to be part of this meet. First, doing this all women meetup. So yeah, it would be a great learning for you guys. I hope so. Welcome to the meetup. Kiran, do you want to go ahead?
Yeah. So today's agenda would be like we will discussing the key features of CloudHub 2.0 with the follow-up with actual use case. We will build actual secure virtual network within CloudHub 2.0 and demonstrate that use case. So do you want us to read, Lavina?
Sure. So just a safe harbor statement before we kick off this event. Both the speaker hosts are organizing this entire meetup at their individual capacity. This presentation is strictly for learning only, and we do not hold any responsibility if the same solution will work for your business use case also. So thank you. Moving on.
So before jumping to actual use case that we are going to build today, so let's understand the few key concept of CloudHub 2.0, which come with various awesome features. With CloudHub 2.0, it comes with it's actually simplify the deployment models. It actually enables your application to run in containerized environment based upon Kubernetes. So I will go through the few key concepts first to make you understand today's use case better. So the first key concept of CloudHub 2.0 is shared and private spaces. So with spaces concept in CloudHub 2.0, which enables you to run your applications in multi-tenant environment, which means we can run our application in common environment, but in shared space. So one application instance will run in one container based upon a Kubernetes, but it will not share the data amongst the application, but it will run in the same environment. So how this architecture would look like in offshore space. So we have a multi-tenant environment in CloudHub 2, where all the application would reside in the same environment, but it would run in the one container, which isolate the data shared between the applications, and it would later consume by the API consumers. So we 12 region where every region have one shared space where we can run our multiple applications. This is about shared space. This is the one concept that when to use shared space. So when we do not need isolation from the public clouds, where we are ready to run our application in our on our public cloud. So it is also when you don't need to connect your on-premise data center, your secure database. So where do you have these kind of requirement? Do you use share private spaces? Your application would run in CloudHub IO domain names. This I just want to share, explain this CloudHub 2.0 domain name. So if I copy this domain name, so this is a syntax, how it's actually a syntax, how your would look like in 2.0. First, you will get the app name that will followed by unique ID, that is shared ID, region name, CloudHub 2.0 IO. And where you will have this kind of example. Let's see what is the So this is your app name, followed by unique ID. This is share ID. This is the region name, and it is followed by the CloudHub.io. If you remember, in CloudHub 1.0, we have app name, region name, and CloudHub.io. So it is slightly different from CloudHub 1.0 name, the app name. So it comes with the unique ID and share ID, where you can actually distinguish between the application is running in 1.0 or 2.0. Moving to the next point, it doesn't support the custom certificates in shared space. When you don't have requirement to use custom certificates, you can use shared space. Let's move into private space. And this is my favorite concept in CloudHub 2.0 so far. So private space is actually a virtual, private, isolated, logical space in CloudHub 2.0, where your applications are running in isolated manner. So, when I'm saying this, what is isolated manner? Let's understand the architecture of private space. So this is the one. This is the actual architecture that I have created to make us understand the private space better. So in Mule runtime panel, we can create a private space, and it is very particular to one region. It's so in one, if suppose I'm creating private space in East 1, and within that private space, I can deploy number of application to run. So the private space one, we the subnet over here. The subnet is actually distinguish between your public cloud to the subnetworking. So when I'm saying subnet, what does that mean? So here I have address of subnetworking CIDR notation, that is 10.0.0.24. 10.24. So see, I actually allocated 256 IPs to this network, and the first usable IP address is this, and last usable IP address is this, to this private space. So I actually create the subnetwork with that I will only accept the traffic that would be under this range. And let me quickly share my screen again. So this subnetworking that we have defined by CIDR notation, and later it will go to the network load balancer. Then we have the concept of ingress private subnet or public set subnet that will allow our application to call within that subnetwork, and will respond back accordingly. So in to communicate, so every region we can create private spaces. So every region we have different, we can create multiple private spaces. To make communication between private spaces, we have another concept called AWS Transit Gateways that my fellow explain about it. And when we can use this private space, what makes you decide that we can use private space? So when you want your application run in the single tenancy environment, you want to make connection to your on-premise data center, and when you want to use vanity domain name. So vanity domain name, I'm just going to explain after this, covering these points. When you are ready to use custom certificates, private endpoints, static application source IP address, in these area we can use our private space. So let us understand what is the vanity domain names, and why I'm talking about vanity domain name. So if this first application, it is deployed under private space, and second application I have deployed under shared space. This first application, if you see, we have ingress where we can actually define our public endpoint that is visible to your public internet. That could be your organization main endpoint, where you want to enter into your network. So here we can define in the private space. In share, we don't have such option to define public endpoint. So this is the public endpoint is already defined. This is disabled. This is what the public point we have, that is the app name, share unique ID, share ID, region, and CloudHub 1.0. So this is the public domain for every traffic. So next is private network. Private network is nothing but that CIDR notation, that is classless interdomain notation, where you can actually create the subnetworking within the public cloud, where you want your traffic needs to be just part of that CIDR range. So we can make connections from the private network. So we can create VPN connection, or we can connect to the transit gateway that Mehak would going to explain you. To you, Mehak.
Thank you so much, Kajal. Sorry, Kiran. So, as Kiran already mentioned, that we have two ways to extend our private space to our external network, which is the customer network. We can either use VPN connection, or we can use transit gateway. So just for comparison purpose, if you guys know, in CloudHub 1.0, we had like 4 methods to do so. We also had AWS direct connect and VPC pairing. We had these 2 options as well in CloudHub 1.0, which are now not available in 2.0. About the VPN and the transient gateway, let me just explain it in detail. So first thing is, the best way to connect to your anypoint private space with your on-premise network securely is using this VPN tunnel, a VPN connection. VPN basically stands for virtual private network. So you can see here, we what happens here is, this connection between the two on-premises encrypted using IPsec protocol. IPsec protocol is nothing but like, it's a group of protocols for having a secure connection between 2 devices. Here we have the 2 devices which I'm talking about are the network gateway. So if you see on the left hand side, we have Anypoint VPC, and there we have the Mule gateway through which all the outbound and inbound traffic enters the VPC or is getting out of the VPC. And similarly, on the on-premise side, we have the customer gateway. And to connect these 2 gateways, we have in between the VPN network using an IPsec tunnel. So basically, in this IPsec protocol, what happens is, your IP addresses to which you have to reach, like the IP addresses of your on-premise data center, which we have to reach from the any point, those are encrypted, along with also authenticating the source. So so we need to make sure that the 2 VPCs which which we are connecting, the CIDR ranges of both these VPCs are mutually exclusive, so that once we connect both these networks, this behaves as a one single big network, and none of the IP address is colliding with the other network. So if we so this VPN tunnel has a lot of benefits. As I said, it uses site-to-site secure protocol, which is IPsec connection. So all your connections going from your Anypoint VPC to your data center are secure on the OSI layer. So also in this MuleSoft gives us capability of using 10 VPN connections per VPC. So for one of your private space, you can connect 10 different VPNs to 10 different VPCs. So we can make 10 different connections per VPC. Also, MuleSoft gives you an ability for high availability of these VPN connections. So basically, you can create 2 similar redundant connections to the same VPC, and because you have redundant connections, if one of your connection is down, you have other connection which can take care of routing your traffic. What else? So also, yeah. Each of your VPN connection will have 2 tunnels, so you can configure 2 tunnels as well. So in case one tunnel is down, the other tunnel is up, and you should be able to have a connection with your on-premise data center. Here, in this particular meetup, we will not focus on the IPsec tunnel because it's a very very old concept, and uh, so we will be talking about the transient gateway more, because this is a very new concept. So similarly to the VPN, we have a method to connect to your outer networks, that is transit gateway. So transit gateway is this by AWS 2018, and just 2 years back, MuleSoft also has given us the opportunity to use this feature. So basically, the main feature of this concept is to have a simplified network. So in transient gateway, what you can do is you can connect to different VPCs, like different AWS VPCs, your on-premise VPCs, or even VPN connections to a single central hub. So if you can see in the center, we have this transient gateway. If you want to connect to your Amazon VPC to any other customer gateway, you just need to have a central transient gateway in between, and this gateway takes care of routing the traffic from your VPC to the other connection. So if we want to connect your Mule VPC to any other network, we just need to pass the traffic to transient gateway. Benefit of using this transient gateway is that it gives you a very simplified network, and you do not need to configure multiple connections if we have a complex network. So if you have multiple customer data centers, you have AWS, you have Azure, you have on-premise, and you have multiple instances of AWS as well, and you want a single network for, you just need to use a transit gateway in between, which can take care of routing all your traffic to different networks. So in this way, all your network will be simplified, and you won't be having multiple point-to-point connections between all your networks, right? And other benefit of using this transient gateway is that it is completely maintained and provided by AWS, so you don't need to take care of the infrastructure management or any downtimes here. Automatically the AWS takes care of all the maintenance here. So uh, obviously in the demo part I will be explaining completely that how these transit gateways are created and how we connect the two different VPCs using this transit gateway. For now, just to understand, you should be aware of some key terms. One is transit gateway attachment. So transit gateway attachment is nothing but the possible connections via your transit gateway. So if you can see in this diagram, we have a private space on the left, which is connected to the transit gateway using the VPC attachment. So these attachment could be of four types. One is like you can connect one VPC to the other VPC. Then other is you can directly connect a VPN to your transit gateway. So if you already have a VPN ready, you can connect your VPN connection directly to the transit gateway as well. You can also connect AWS Direct Connect Gateway to this transient gateway. And along with that, you can connect two transient gateway within itself as well. So for example, your one transient gateway is in east region and your other transit gateway is in west region, and you want to have a region to region connectivity. So you can also use pairing to connect these two transient gateway into one. um, Moving forward, we have now to understand how basically this transient gateway route the traffic. Kiran, can you just go to the next slide?
Yep.
Okay, so to understand that how basically these transient gateway route the traffic, we have a concept of route table. So each transient gateway maintains a route table in itself, where you mention the CIDR of the destination address. So for example, I want to go to VPC B from VPC A. So I need to mention here the CIDR range of VPC B, that whenever my destination address lies in the CIDR range of VPC B, I need to forward my traffic to VPC V. So here you can see on the left hand side, we have the destination CIDR, where you will be mentioning the CIDR range, for example, 10.0.0/24, which means whenever I want to reach to any of the IP in this CIDR range, the target will be VPC-A. So you have to go to VPC-A. So this type of route tables are maintained in the transit gateway, which are responsible for the particular routing. When we will move to the demo part, we will be explaining this in detail. For now, we have like other concepts in CloudHub 2.0 as well. I would say if Kajal, you can explain the other concepts as well.
Sure. Thank you, Mehak.
Thank you.
Yeah. So, Ingress load balancer and like my last mile security. So, as in CloudHub 2.0, we have Ingress controller, which replaces the dedicated load balancer we have in CloudHub 1. So, when we needs to like balance the load in CloudHub 1, so we use this DLB, but in 2.0 we have a option Ingress controller. So, in this, it will give us access to both public and private balancer can be configured for ingress controller. In order for you can like we have clients and client is trying to connect to the cluster. In the cluster we have like nodes. So clients wants to connect with the like my mule application. So client either will be giving connecting from http or https. So for http we have a default port of which is 80, and for https we have a default port which is 443. So whenever my request client is requesting to mule app, so the request will land on ingress, and ingress then convert route my request as a, because our cloud hub 2.0 just accept the port as a 8081. Our applications are running on this server only. So ingress will for route my application as a like 8081 to this mule applications. So then we have next is mule mtls, which is like mutual transport layer security. So what it means, like mtls ensures that the parties at each end, like client and server, presents the TLS certificate. Then it again came back to the client and verifies that yes, it's the correct certificate that should be present on the server certificate. Then the fourth step, like when we doing SSL like one way certification, it just check the certificate on server level, but doesn't check the certificate on the client level. But in MTLS, like in the mutual TLS, we need to check the certificate. It check the certificates on the both also and on the server side also. So on the fourth step, what it will do, as shown in the diagram also, it will check the then client presents the TLS certificate, then server verifies yes, this is the client certificate, then server grants to the client to get the data, like client is requesting some data from the server. So the connection between server and client is happen after the like after on the both side, on the client side, then the encrypted TLS connection will made between client and server. Okay, so then we have, I think, like security means like when our ingress is trying to connect with our mule application. So whenever ingress is trying to connect with mule application, so there last mile security means that the connection between ingress and actual mule app will be https. So however, whenever the we like ingress tries to connect with this, like ingress will trust any certificate provided by the mule app. This means self-assigned certificates also can be accepted by ingress, invalid cn, invalid san, and expired certificates also are accepted by ingress. The reason behind this is that management of the certificate should be done at the ingress level only, requiring each and every mule application to have a valid certificate will also mean that the ingress needs to update to contain every single app's corresponding certificate, because this is not a feasible, like the each mule application certificate we needs to have on the ingress level also. So last mile security allows ingress to trust any certificate provided by the mule app. Commonly a self-assigned certificate is used as a placeholder at the mule http listener level. So with last mile security, what we can do, like as you can see in the diagram, whenever my request my request land on the ingress. So it will whenever it is giving from ingress to I am connecting to my Mule application, it converts my request to the HTTPS so that it is a secured connection between ingress to worker, like my Mule application. Yeah, and now we can move to use case. Kiran,
Thank you,
over
Kajal.
to you.
So I hope we are ready to understand today's use case. So far, what we have discussed, we have discussion about shared space, private space, transit gateway attachments, and how to connect private space to other private space through the help of transit gateways. So let's actually understand the today's use case that we are going to demonstrate to you guys. Let's
Kiran, if I can pause you
today's
for
use
a
case.
quick second. We have two questions that are there in our Q&A.
Okay.
If we just want to answer those and then move on. The first question is, what is shared ID and what is the difference between shared ID and unique ID?
Then shared ID is a common between the shared space, and unique ID is very specific to the app ID. So app ID, it's a it is a very corresponding to the app we are deploying. It's very specific.
Thank you. Can I add DNS names instead of IPs?
We don't have privilege to add. Are you talking about cider notation? Can you
Yes.
confirm?
Yes.
Okay. Okay, so we don't have that option to enter a domain DNS name instead of CIDR notation. So we need to have a very specific CIDR notation that which part of the IPs we are going to use, which part of subnetworking we are going to use to create our private network.
We have another question. If we add entrusted certs at the ingress level, wouldn't this lead to security breach?
I would like Kajal to answer this question. Kajal, do you want to answer this question?
Like in CloudHub 2.0, we can add this certificate on private space only. So I don't think so. It's like a security breach because we are adding it on the private. No one from the outside can access.
Thank you. Is vanity domain is replacement of proxy app in CloudHub 1.0?
It's a very different concept, vanity domain and proxy URL. It's mutual exclusive, but not replacement actually. So we are actually passing our traffic from vanity domain to our actual APIs through network load balancer. So yeah.
Thank you. That's all we have on our Q&A. We can move over to our use case. Thank you, everyone.
Thank you.
This is our today use case that we are going to demonstrate you guys.
So we have created it's a one of the virtual network in one way actually, one way to create virtual network in CloudHub 2.0. So if we understood the private spaces, if we understood the transit gateway, if we understood the ingress load balancer, if we understand the internet gateway, if we understand the region as well. So this use case just make you this will understand you better. What we are going to do, so we will create two private spaces in the US East 1 region, where we, in private space 1, the IP address, we will have one side notation for private space 1, we will have one side notation for private space 2. And in private space 1, we will reside experience API. We will deploy our experience API that is accessible to the public internet. So we can only access experience API through the And in the second private space, we will deploy our process and system API, which has no connectivity to the public environment, a public network. So this is how we can actually isolate our experience and process and system API. And this process and system API will directly communicating to our corporate database through VPN IPsec tunnel. And two private spaces will communicate through transit gateway. And this transit gateway is also attached to the AWS service, that is AWS RDS database service, um, uh, t- uh, to access the database from AWS. This is also in the same region, the US East one. We can by our and we can make use of RDS database in another region as well. So we can connect to those region. Uh, sorry, through we can connect to multiple regions through the transit gateway. So how that communication happens when we are saying that we can communicate from the different region as well. So we will have the transit gateway in that region as well. So that communication is transit gateway to transit gateway communication. So in today's use case, we are just we will have our API deployed in East one. We will have our AWS RDS database reside in East one in the same region itself. So Mehak will demonstrate you how to create private spaces, how going to use service of AWS RDS database through the private space. Also, we have actually this this AWS database is reside on this IP decider notation. I hope we understand this use case, because it's very important to understand this use case to actually actually go. Can somebody give a thumbs up in the chat? I can't see the chat, Lavina.
Yes.
Yes,
Yes,
yes, we
Kiran, we
can.
got
Okay.
some thumbs ups.
Yeah.
Oh, cool. So let's proceed with the demonstration. Mehak, over to you.
Thank you. Thank you, Kiran. Let me just share my screen. Can you stop sharing? Okay. Just a sec. Yeah. Do let me know once my screen is visible.
Yes, Mehak, we can see.
Okay, so first we will learn how to create a private space. So if you can see here, I already have one private space here because it takes some time to create it, to create it. So I'll just directly show you the configuration. So to create a private space, firstly you should just name it according to your requirement. Name that private space. We need to give the region where this private space would lie, and then comes the CIDR block, which we already talked about. This is nothing but the address of this private space. So all your applications which will be deployed in this particular space will have an IP from this CIDR range only. Okay. Then once you so with only these two configurations, that is region and the CIDR block, you should be able to create a private network. Okay. Automatically, once you create this private network,
So sorry about this. I think it looks like there's some connectivity issues. I think Mehak will join back in just a second. I think she just dropped off.
Meanwhile, Kiran, go with like TLS configurations and
Yeah, go ahead.
so that we don't. So as Mehak was showing the private space that this she has created the like we have created USEs. One second. In this private space, we when we create in the we just for the private network we just need to give the reason and CIDR range for this one, and then these private DNS target inbound static IPs, outbound static IPs, this will come automatically. Like it will take up to 30 minutes, then it will come automatically. Then next we have domains and TLS. Like for the mutual TLS, so we have this option here in the private space. So in the key store, we need to configure our public certificate and private key, and then we can use Trust Store to add the client side certificates, and this one we can use for server side certificate. So this way we can achieve mutual TLS. Then next we have firewall rules, and then with a CloudHub 2.0 like private space we can control inbound and outbound traffic both. So we can define our firewall rules here in this tab. So inbound rules, like currently we have HTTP and HTTPS, and as I mentioned earlier the port is 80 and 88443 for this one. And next we have advanced tab. This is for like the, as you can see that there is a HTTP request, so it has three different type of options. We have direct, whenever request land in an ingress, so it will redirect it to HTTPS. To accept HTTPS, it will accept the HTTP. When we enable this option, it will accept the HTTP as it is, and when we enable drop HTTP, it will just silently drop the HTTP and move to next. So here is the option where we can download the ingress load balancer logs, and like different type of logs also from here, like error, debug, trace, and info. And we can get the logs of custom. We can add the IPs here, and we can get the logs from here also. So yeah, that's about like I guess.
Kajal,
Mehak,
Mehak has joined. Mehak,
yeah, Mehak, you can continue now.
Yeah, I'm so sorry, guys. I'm not sure what happened to my network.
no
Uh,
worries.
I'll start again. Okay. I'm not sure from where I dropped off, so just let me know if we are we like everybody knows like what firewall rules are applied to a private space.
You can explain, Mehak. Let's explain private space 1 and 2.
Okay, so as I mentioned, so this is the private space we created, and on this private space, we can apply different firewall rules according to the traffic which we want to allow to this private space. So if I want that this private space can be reached from anywhere over the internet, I would say that the inbound traffic can come from anywhere. But if I don't want my private space to be reachable from an outer network, I will say the inbound traffic should come only from the local network. Okay, so that is how these firewall rules helps you define the security of your define the privacy of your private space. um, Now let me just show you the applications which we deployed. Okay, so if you can see my screen, I have a system API, which is AWS Customer System API. This API is nothing but it connects to the AWS database which we created. So if you see here, we created a simple database in AWS, and we made sure that this database is not publicly accessible. So so if anybody outside the network of this particular database, which lies in the AWS region, VPC region, he or she will not be able to access this particular database. So what we want is that only via the MuleSoft VPC, we should be able to reach this particular VPC, that is AWS VPC. So we need to make a connection between MuleSoft VPC and AWS VPC. To make this connection, what we did is, so this is my private space. To make this connection, we use transit gateway here. So if you can see here, I have already a connection here. So first, to create a connection, first you need is a transient gateway in AWS. So if you can see, this is the transient gateway that we created. So uh, y- whenever you create a transient gateway in AWS, you will get a transient gateway ID and an owner ID along with that. And now to connect this particular transient gateway to your anypoint private space, all you need to do is you need to create a connection. So I'll also show you how we can create one. I'll create a new transient space. Say TS10 demo. So once we create a transient space, we need to mention the IP routes to which this transient gateway can route to. So as we want to route to the AWS, so here I will put the IP address of the AWS server. So as you can see, this is my database which lies on this VPC, and this is the CIDR range of my VPC. So I just need to put the same CIDR range over here so that my transient gateway can connect to that VPC. Okay, so you just need to go to next, and once you create that uh, CIDR range, you need to create a resource share here in AWS. All the steps are already mentioned over here. You just need to sign into AWS. You need to create a resource share. Once you create a resource share, I'll just not create a new one. I'll show you the already existing one. Um, just a sec. Yeah. So as you can see, this is the resource share which is created. So once you create a resource share, you will get ID and the owner number. Resource share is nothing but where we define that this particular AWS VPC is to be shared with the transient gateway. Now you just need to give these particular IDs here. Here. Okay, so as I have already done it, I'll not do it again. So once you create a resource share, you need to give your resource share ID and owner ID in anypoint private space. Once you are done this as well, you should be able to see an attachment like this here. So basically what we did is we created a transient space, a transient gateway in AWS. Then to connect that transient gateway to this anypoint VPC, we create a VPC attachment. So using this attachment, now this Mule VPC is able to connect to the AWS transient gateway. Okay. So once this connection is successful, now you should be able to reach to the any point you should be able to reach to the AWS database. So if you see, I have deployed the same application, that is the customer system API, on private space, my private space 2, which is already connected to the AWS instance, and one on the shared space. So shared space is somewhere is where we can reach to this application from any network. Okay. So you would know that if I call my shared space API, so this is the URL for my shared space API. If I try to reach it, it will give me an error. I have already this error on my screen. So if you can see, this error says you cannot connect to this connection, the
Yeah,
AWS connection.
we can't see it.
Oh, just a second. Let me share my entire screen. Is it visible now?
Yeah, yes.
Okay, so if you can see here, this is the URL for my shared space application. So if I try to reach this URL, I'll get this error that you cannot connect to the AWS instance. This is because your application is deployed in shared space and the shared space is not connected to your anypoint to your AWS instance. Whereas the same application I deployed in the private space as well, and I should be able to reach to this to my AWS instance via this API. But before that, there is a catch here. Mm-mm. So if you see here, what I did is I disabled the public endpoint for this customer API. So which means that this API should not be accessible via any outside network. So from my local, I won't be able to call my API which resides in my private space. So if you will run this application, this particular URL, you will get an error that 404 not found because I have disabled the public endpoint just for testing purpose. So this is the same URL as you can see. This is the URL to my application, and using this URL, I'll try to call the AWS instance. And here you can see I got all the data. So basically, um, I'm able to connect to that AWS instance from within my network because this NetTool application is deployed in private space only. So if you see this NetTool application, this is just an application which can be used for pinging outer systems and checking your connectivity. So I have deployed this NetTools in the same private space. So I should be able to reach to this API only via my private space. So using this NetTool API, I can reach that API, but from my local, I won't be able to reach this particular API. Okay. But now for security purposes, as I already mentioned, we made sure that this API is not publicly accessible. But then for the use case purpose, now we have to get that data somehow, right? So what we did is we created an experience API and deployed it into the same space. So now via this experience API, we should be able to call this system API. So because this experience API lies in the same space, the experience API will be able to call the system API, and the system API will be able to call our AWS instance. And for this experience API, we kept the public endpoint as it is because we want to call it from our local. So if I call my experience API, I should be able to get the data from the RDS, right? So you can see this is the data which resides in the RDS. So uh, to brief it out, what we did is we created a system API in a private space, and we made sure that that system API is not publicly accessible, and that is why we removed the public endpoint. You simply have to go here and cross this public endpoint and apply the changes. Doing this public endpoint will not be available for that particular API. So we created an system API which is not accessible publicly, and then we created an experience API in the same private space, and using that experience API we are reaching that public that system API. So now nobody from your outside system should be able to connect to your RDS, but only the application which reside in your private space, that is only the trusted applications. So for example, this experience API is a trusted application, can reach to that system API. So this is how the whole security is built when we say we want to connect two different networks. This is how we make sure that we are keeping the security in mind. um, let me know if there are any questions. Just a sec. What's the use of cider block? I think Siva has already answered it. Do we have any other questions? Okay, so as we know that according to the use case, I have only explained the transient gateway part. Due to the time constraint, we will not be explaining the VPN, Azure VPN part in this particular meetup, but definitely we will come up with another meetup so that we can explain the whole scenario. But in this meetup, we learned that how we can connect two different VPCs. One is the Anypoint VPC and the AWS VPC using a transient gateway. Yeah. That's all. I'll stop sharing.
Mehak, we
Kiran,
have
do
one
you?
We have
question.
one question, Mehak. Somebody, Bipin Singh is asking, can you show the firewall rules once?
Sure, sure. Just a second. Am I sharing my screen?
Not yet.
Yeah.
Okay, okay. Let me share my screen just a sec. Is my screen visible?
Yes.
Yeah.
So here are the firewall rules. Do you want me to explain them?
Please say
So as it's visible that we have made sure that any inbound traffic to this private space is not allowed, and we only the outbound traffic to this private space is allowed. So for outbound traffic, we made sure that from anywhere, like we should be able to reach any IP over the public internet. And for the inbound traffic, we had made sure that only via the local network we should be able to reach this private space.
Yeah, that's great.
Yeah. Any other questions?
No, I think that's about it. So let's, I think, hop on to the trivia now.
Yeah.
Manpreet, I just want to take a quick pause just to make sure, because we're already on top of the hour. Top of the hour as per the planned. Just by a thumbs up, do we have maybe 10, 15 more minutes just for us to run through the trivia? We just want to be very cognizant of your time, since for many of us it's early in the morning, and for the others we're starting off work if it is our IST time.
I can see lots of thumbs up.
Yeah. Okay, let's go for it then.
All right.
Thanks, Manpreet.
So let's just hop on to the trivia really quick. Let me just share my screen with you. So guys, you can see the QR code right there, right? So you just need to scan the QR code and enter the quiz. And please, it's a request. Please write your real names and full names so that we know who are the winners. It becomes easier for us. Okay, whoever is IS, can you just exit and come again and write your full name so that we know who you are? Thanks. Let's just wait for 1 minute. Okay, so rules are very simple, right? It's fastest finger first. The one who answers the fastest and gets the most number of correct answers will be having the highest scores as compared to the ones who answer slowly. So you have to be very quick when you're answering the questions. I think I should start. Should I start?
Yeah, Manpreet, let's get started.
Let's get started. Okay, great. So guys, starting with the quiz, time to go head to head and compete for top spot on the podium, right? Okay, let's. So first question is just to find out how excited you are to take the quiz. So you have only
The
10
best
seconds.
slide ever.
So you can drop your pins on Zoom if you're very excited, if you're excited and make it. And time's up. Okay, so most of you are really excited to take the quiz. Good to know that. Let's move on to the questions. Which functionality is not available in CloudHub 2.0? The subject has multiple correct answers. You have to select two answers. So let's see who got it right. So we have Ishilveer on top of the scoreboard, followed by Subhajit and Bhavya. Moving on to the next question, which is a puzzle. So define the sequence for connecting AWS VPC with Anypoint VPC using Transit Gateway. You just have to arrange this in the correct order, and you have 30 seconds to answer this. So you can just drag and arrange it in the correct order. order was create transit gateway in AWS, then create resource share in AWS, configure transit gateway in CloudHub, and then finally attach and accept VPC attachment. Let's check the scoreboard. So Bipin has climbed on to the first spot, followed by Ivan Rodriguez and Jatin Singh. And then we have Anuj and Achleshwar as the new entrants in the 4th and 5th spot. Okay, great. Moving on to the next question, which is a true or false. So in CloudHub 2.0, port 8081 is used for HTTP and 808 HTTPS. 5 seconds to go. And time's up. The correct answer was false, and only 8 people have got it right. Bipin is again leading, followed by Subhachid and Shreyanshi. And Ramachandran is the highest climber. Okay, next question. Maximum number of VPN connections that can be configured with single VPC. So you have to select the right number. Okay, let's find out what the correct answer is. So the correct answer is 10. And 14 people have got this right. So Bipin is still maintaining his top spot, followed by Subhachid and Bhavya. Next is type the answer. Built-in load balancer 2.0 is called what? Make sure you don't make any spelling mistakes while typing, otherwise you get it all wrong. Let's see what the correct answer is. The correct answer was ingress. 10 people have got this right. So now, if you can just tell us about your experience of today's meetup. You have 30 seconds to tell us about your experience before we share the final scoreboard with you. Oh, this is great. So awesome, informative, in core, excellent, great, good, insightful, wonderful session, lovely. And okay, Independence Day, I don't know what that means. Okay, great. Yeah. All right. Let's move on to the scoreboard to figure out who the winners are. So on 3rd spot, we have Bipin Singh. On 2nd spot, we have Subhachi, and the winner of the quiz is Bhavya. So a big congratulations to all the winners here. Let me just stop sharing. So thank you everyone for being here. Hope you enjoyed the session. Lavina, you want to add something?
No, same thing. Just going to reiterate. Thank you so much. Thank you for spending 10 extra minutes with us. It's always a pleasure. Stay tuned with our Women in Tech series. There's lots more coming up, as I mentioned. So we'll be looking forward to kind of connecting with all of you all. So feel free to reach out to our amazing speakers. I know they did a great job. So thank you, Kajal, Mehak, Kiran, Manpreet, thank you for everything, for putting all of this together. Yeah, it's always teamwork, and this clearly showed in our amazing Women in Tech series. So thank you, everyone, and hope to see you guys soon again.
Thanks, everybody. Thanks for joining.
Thanks, everyone.